Okay, everybody, looks like it's noon, so we'll go ahead and get going. As I said, my intention is to post this on YouTube after we're done this afternoon, so you'll be able to go back to it, and or if somebody you know isn't able to join us live, you can let them know. I'll make an announcement as well. But what I want to do, first of all, if you don't mind, is just go over some of the details about the quiz, since this is our first quiz. Now, you may not have yeah, or I know that you can't see this announcement yet. It will become available to you in your announcements at the same time the quiz becomes available to you, and that's at 2 o'clock this afternoon. So the what we're going to do is just go over some of the details of the quiz. And by the way, if at any point you need to ask a question, feel free to interrupt me. Just take yourself off mute and ask your question. Or also, there's a chat box if you want to submit your comment or question in the chat box. I'll be looking at that as well. Okay, so this is the first quiz where we're going to use Honor Lock. And these are weekly quizzes. We'll start having them every weekend. So this is my recommended preparation. You can see that here. So you've been doing the lessons for the week, in this case, 2 weeks. And they're good learning opportunities, but they're also, opportunities to earn some points. So just make sure that you've completed all those and you maxed out all of the points. There's no late penalties. There's an infinite number of attempts. So just keep trying them until you get all the points maxed out on that. And that will help you learn the material as well. Now, also in not all, but many of the handouts, there are additional problems that you can do and you practice those. Unfortunately, you don't have the key. I brought it to class. I forgot to bring it yesterday to lab, but it's still good to try and attempt those end of handout questions, help you learn it and get more proficient at the different problem types. So there is an additional problem set, which I'll show you in just a second. It's in the week 2 lesson handouts folder. Okay, so if you go again to course home, you go to lesson handouts, week 2. And so right here is like additional practice problems with a key. So recommend that, making that part of your preparation as well. Okay. We'll go back to the announcement. So we've done, of course, every day we've had a practice problem set. We worked in class. So I have converted all of those from in class to practice problem sets in active chemistry. And so you could do those again. That's another way to prepare. And then this one right here, at the end of each handout, I have made a list of recommended end of chapter questions. One little caveat about that. So I made that list based on the 9th edition of McMurray's textbook, and we're currently using the 10th edition. So you may run into a question and you look at the question and you kind of scratch your head. You're like, oh, that doesn't look familiar. So don't worry about it. That's legit. That's probably because it's a difference between the 9th edition and the 10th edition. I've just started combing through those to update them for the 10th edition. I haven't got very far. So, but it's not a big deal. I don't think it affects a whole lot of questions. And then, of course, a good thing to do in general is to make some flashcards for important terms, trends, concepts. Like if you wanted to do the functional groups, write the name of the functional group on one side and then the generic structure of the functional group on the other side. That's a good way to help you memorize all those. Okay, a little bit about the quizzes themselves. So they will be a mix of question type. There'll be calculation, there'll be fill in the blank, there'll be multiple choice, there'll be matching, there'll be select all the correct answers. There'll be the jumbled sentence kind. That's where you're given a sentence or sentences with there are places in the sentence where there's be a drop down menu and you choose the correct word or phrase that makes the sentence correct. So that's what I mean by jumbled sentence. There'll be some ranking and ordering questions or maybe some hotspot type questions. That's where you like click on the most electronegative atom. That's where you click on a picture somewhere about something. That's what we mean by hotspot. Okay, so each attempt has a 30-minute time limit, which I've never heard anybody complain about, so it should be plenty of time to relax and just check your work, make sure you review everything you've answered before you submit it for grading. okay? And of course, remember that you have 2 attempts. So after your first attempt, go back and look at your results because it will tell you which questions you got wrong, and try and understand why you got it wrong. Okay, think about that question some more. See if you can figure out why you got it wrong. Now, and I would recommend whatever that topic is, to go back and review that topic, shore up your knowledge of that topic. Because when you take the second attempt, it might be the same question, it might not be. A lot of the quiz questions are just randomly pulled from pools. But all of the pools for a given, question number 3, for example, all the questions in the question 3 pool are very similar. So even if you don't get the same question, you'll, if you went back and studied that topic some more, then you're much more likely to get it right on your second attempt. And in general, just from my experience, students do much better on the second attempt than they did on the first. So especially if you take the time to do what I just recommended. Review the questions that you got wrong, figure out why you got it wrong, go back and review that topic. You got a much better chance of getting a great score on the second attempt. Both quiz attempts are due this Sunday night at 11:59. Okay, now, if that's a problem because of your work schedule or childcare or many possible things, just send me an email, let me know, and more than likely you'll get an extension. Okay, just I want to know about it ahead of time. Okay, so hopefully everybody has some experience with HonorLock, but if you have not, it is the remote proctoring system that MSS. I told you I'm not feeling well, so if I sound a little loopy or say something stupid, I can blame it on that today. But HonorLock, so MSSU, this is their remote proctoring system. So what you should do for my quizzes that are proctored with HonorLock is print off that official equation sheet and periodic table. Again, if you go to it's the one you've been using in class, but you'll get a clean copy if you go to important admin documents and you click that document right there. So download that. And I recommend downloading and printing it. And HonorLock freaks out if you try and switch between windows and things like that. So you should actually print that off for your use on the quizzes. All right. Okay. And of course, you can't have any extra notes on them. No writing is allowed on that. And you can't use a different one. If there's another one that you prefer, sorry, you can't use it. Okay, so with HonorLock, you have to have your student ID. You are allowed clean scratch paper, a pencil or pen, and a calculator. So you can't use your phone as a calculator. HonorLock will sense your phone, and it will give me a big old red flag. So you probably will get a pop-in visit if you do have your phone detected. So just a regular calculator, please. Okay, make sure your laptop is charged and all of your system software, operating system software is updated. Okay, and your internet is strong. Well, those are the most common issues with HonorLock failures. Okay, and when I say failures, I don't mean failure on the quiz, just it doesn't work right, technical difficulty, and makes it challenging to get it all done and accomplished. Okay, make sure you're in a quiet location because once again, it does pick up background noise and will give me an alert. It's a mild kind of alarm, and I don't really care if if somebody walks through the room or not a big deal, but I think it's in your best interest to pick a place that's fairly quiet and fairly isolated. Okay, so once again, with HonorLock, you have to do something called a room scan. Okay, so that's where you show the webcam your equation sheet, your periodic table, the blank scratch paper, and your immediate work area. Okay, so that you kind of prove that you're not using some sort of extra resource that gives you an unfair advantage. All right. And if you run into any trouble with HonorLock, there is that little button for live chat for tech support, but you can also email support@honorlock.com. And again, just let me know if it's not working right. If you have technical difficulty that's going to prevent you from getting it done on time, just send me an email and we'll deal with it. Not a huge problem. Okay. All right. So that's my all the administrative kind of information about week 1 and 2 quiz. So I'll pause for a second. Does anybody have a question? Again, just take yourself off mute or type it in the chat box. Okay. So how many questions are on the quizzes? Typically 12 to, there's anywhere in the range of 10 to 15. I believe this one has 12. And I can't promise every time, but most of the quizzes, when when you open it up, it will tell you. It will say, how many points it is and how many questions it is. There may be one or two quizzes where I neglected to include those details, but in general, 10 to 15 questions, 70. No. Like usually they're in the range of like around 25 to 35 points. The reason why I think I said 70. If I said 70 again, that's because I'm not feeling well, but also my Chem 1 quizzes are 70 points. So that's why. Okay. So now what I'm going to do is I'm going to change over to a problem set. Oh, wait, we got one more question. After taking your second attempt, does it take the best score? Yes, it counts the highest score is kept. All righty. If you think of any other questions related to that, feel free to go ahead and submit it. I'm going to go ahead and go to our active chemistry problem set for today. So let me start this. Okay, so you should be able to follow along. I'm just going to demonstrate the solution to all of these. So let's take a look at this first one here. And again, just, don't be shy about interrupting me if you have any questions along the way. But this one says, we'll write the condensed noble gas electron configuration of magnesium. Okay. And so if you look at a periodic table, the nearest noble gas for magnesium is neon. So that's going to be the starter, since this is the condensed or noble gas electron configuration version. And then we pick it up with the third shell, the third period. So we go 3, and then S, and it's got both electrons there, and then that's it. Okay, magnesium is in group 2. So I believe that is the correct answer. Okay, so make sure you know how to do electron configurations and or interpret electron configurations. Okay. Oh, I didn't start that one. You know what? I'm just going to start all these at the same time. Sorry about that. I forgot to start it. Okay, so I'll give you a second to work on that one. Okay, next question. Question number 2. One of the big topics from weeks 1 and 2 is interpreting these line or skeletal structures. Okay, what do they mean? Okay, so this one, for example, asks us how many pi bonds are present. Okay, so what I want you to remember is that a pi bond is present every time you have a double bond or a triple bond. If a double bond is there, it's 1 pi bond. If it's a triple bond, it's 2 pi bonds. So here's 1, 2, 3, 4, 5, 6, 7, 8. Oops, it went away. 9, 10. I think it's 13. Yeah, I apologize. Sometimes these active chemistry, it depends on the browser, I know. It makes the picture go away. If I'm not mistaken, it was the answer. Correct answer was 13. Yeah. Okay. So the point being is just, there are other questions about this, like this in this problem set. This is the new stuff. This problem set, it focuses more on the organic chemistry, newer topics that we've learned in the past couple of weeks, more so than it does the review topics from Gen Chem 1 and 2, just because it's, it is the newer information. All right, very good. So you guys are getting that. Good. Okay, so number 3 here. So it looks like people have moved on. That's okay. So in this case, it asks for the carbon oxygen sigma bonds. Now, the one thing the reason why I picked this one is because remember that there is, well, first of all, a carbon atom. There's a carbon atom right there, and there is a double bond. So with every double bond, there is both a sigma bond and a pi bond. So these two lines represent, it's left away. I have to, oh boy, so I'm gonna have to deal with that apparently. Sorry. Okay, so how many carbon oxygen sigma bonds? Well, there's one there, there's one there, and there's one there. So the correct answer is 3. Okay. All right, so yeah, those of you who said 2 probably are neglecting that carbon oxygen double bond. If you said 12, you may have just overlooked it says carbon oxygen. Okay, so they're talking about the carbon oxygen sigma bonds. That's what I think is going on for anybody who says 12. I think that's what you're probably doing, is counting the carbon-carbon bonds. Okay, so number 4 here. Okay, so hybridization. All right, so in general, remember, this question is kind of a twofer. It's a reviews functional groups, but also valence bond theory. So remember that the general structure for a carboxylic acid is you have some carbon-containing group attached to a carbon with a double bond to an oxygen, and which is attached to an OH. Okay, that is a carboxylic acid. Okay, so we are trying to determine the hybridization of the carbon atom. So the carbon atom, we're talking about that one right there. And so remember that the hybridization can be determined based on the steric number. Okay, and this carbon right here is attached to a carbon over here, an oxygen over here, and an oxygen over here. So that's 3 atoms, and it doesn't have any lone pairs on it, so 0 lone pairs. So it has a steric number of 3. And so you just memorize when it's steric number of 3, it's 2 things. It's trigonal planar in geometry, but the other thing that tells you is it's sp2 hybridized. Okay, so that is an important skill to have in this course, being able to look at a structure and come up with the hybridization pattern on any given atom, right? Because we're going to talk about how certain properties depend on that hybridization. That's really how we're going to reference it. Okay, so what I'm going to choose is sp2. Okay, and that's the correct answer. Okay. Why did that one not start? That's weird. Somehow So sorry about that. Hopefully you remember my discussion and can answer it now. We're having all kinds of technical difficulty. Hopefully that's not an omen of your experience with the quiz this weekend. I don't think it will be. Let's think positive. Okay, good. All right, so that was number 4. Let's do number 5 here. Oh, that's what the problem is. I clicked that. Okay, my bad. Okay, so once again, let's just look at this picture here. Okay, and let's determine the hybridization on this carbon right here. That's carbon because it's gray. You'll kind of learn there's typical colors used for the different elements, and gray for carbon, red for oxygen, blue for nitrogen, white for hydrogen. But this carbon right here, if I were to determine its steric number, okay, you see that it's got a steric number of 2 because it's connected to 2 atoms. That atom, that and the other atom, so that's 2. And it doesn't have any lone pairs on it. And you know it doesn't have any lone pairs on it because it has 4 bonds. 1, and then there's 3 bonds right there. So it's got its octet. There's 2 electrons there, and then 2 electrons with each of these bonds. So it's got an octet. So we don't need to add lone pairs on this atom to give it an octet. You would to like this oxygen atom. It's got 2, 4, so it doesn't have its 8 electrons. So you would give it 2 lone pairs of electrons. But I don't need to do that to this carbon. And so that means since it has the 2 connections to atoms and no lone pairs, it has a steric number of 2, and that means it's linear. Okay, you memorize that when it's got a steric number of 2, that means it's linear, and that means that it's sp hybridized. Okay. All right. Okay, yeah. So if you said sp3, remember that's your, I don't know what you're thinking about, looking at the wrong atom or something, but it's based on the sp3 would be connection to 4 different electron domains, either 4 different atoms or a combination of 4 different atoms and lone pairs. Okay. Next one, predicted bond angle. Okay, a lot of you already have this one right. So once again, the reason why I put this question in the problem set is remember that the hybridization also determines the ideal bond angle. Okay, so since this atom right there, there's an implied hydrogen that's not shown. Remember, that's one of the features of these skeletal drawings is that hydrogen are implied to give the carbon 4 bonds. Since I only see with this carbon right there, I only see 3 of the bonds. There's 1 bond there. There's a double bond here, so I don't see all 4 bonds. That means there is an implied bond to hydrogen there as well. Okay, and so again, that means I've got a steric number equal to 3, no lone pairs on it. Okay, which means sp2, which means an ideal bond angle of 120 degrees. So that's what I want to choose. Okay. Okay, good. Oh, we've had somebody else join us. Oh, good. Or somebody's doing it on their own later, somewhere else. Okay, so I think that was number 6. Let's do number 7 here. Yeah, some of you guys are going ahead. That's fine. So this is just, again, a kind of a review of your knowledge of periodic table. And based on the position in the periodic table, the element with 7 valence electrons, that would be the one that's in that's a halogen that's in group 17. And so that's bromine. So again, just general chemistry review. Do you remember how to determine how many valence electrons an element has? And again, it's based on its position in the periodic table. Okay. All right, number 8 here. Yeah, so here, let's talk about this one because several people are getting it incorrect. So this one again, which of the structures below has the fewest hydrogen atoms? Well, you just got to start counting hydrogens on these, okay? Start counting hydrogens. So hopefully the picture will stay here. So there's a hydrogen here, there's a hydrogen here, there's a hydrogen here, there's one here. Now there's not one here because this carbon has 4 bonds. 1, 2, 3, 4. And there's not one here. So this carbon has 4 bonds. 1, 2, 3, 4. So there's a hydrogen here. There's a hydrogen here. There's a hydrogen here. There's a hydrogen here. So sorry about my chicken scratch. This is the total of 1, 2, 3, 4, 5, 6, 7, 8. Oh boy. My meeting will end in 10 minutes. Huh. Apparently I've got a limit on the number of minutes I have for these meetings. I didn't know that. That's a new thing. Anyway, so now you get the idea on how to answer this question. You just got to, based on the skeletal structure, you got to figure out how many hydrogens are present. Okay, so now I've at least talked about how to do it. So I'll let you do that one on your own. But just remember sort of some of the important features of the skeletal drawings. As I've said before, that the bonds between carbons are shown, but the bonds between carbon and hydrogen are not shown. So there's some practice with that one. Okay. All right, so I'll just show you the answer. Okay, the answer to that one is A. Okay. So yeah, several of you got that one wrong. So since this is I'm gonna make this. I'll turn this into a practice problem set so you can try it again later if you want. Okay, so got like a few minutes left. I've got 8 minutes left, so let's try and get a couple more done, I guess. Okay, so how many carbon atoms are in the skeletal structure? Okay, it looks like you're having good success with this one. That's easier. So you just count the ends of lines or the intersection of lines. So that one's okay. We won't demonstrate that one. Number 11 here, what is the empirical formula of methamphetamine? Again, can you just look at that picture? Okay, can you look at that picture and come up with the empirical formula? Again, do you know how to interpret these skeletal drawings, these line drawings? And you should count 10 carbons, 15 hydrogens, and 1 nitrogen. Okay, so it looks like somebody just counted the number of hydrogens wrong. So make sure you're doing that. Okay, let's see, 12. So again, where are all the hydrogens? Find all the hydrogens. Looking at this, the one that people miss, I'll go ahead and point out. Oh, it missed. It didn't show up. Let me go back. Okay, so real quick, let me just try and draw this on here before it disappears on me. Ah, I'll just draw it. So when you have a tertiary carbon, something like this, a lot of times people will forget. I am not having a good experience with this. Sorry. A lot of people will forget that there actually is a hydrogen there. Okay, it's just not shown sometimes. Okay. Okay. One that I did skip over was number 10 here, draw the skeletal bond line structure. And part of the reason why that is because, in Blackboard for the quiz, you don't have to use the drawing tool. So I'm, that one is mostly about, hey, do you know how to use the drawing tool? So I'm not worried about that too much. So identify the molecular formula in number 13 here. I don't know why. I think I've changed windows, perhaps. Okay, well, now it's really crapped out on me. I can't even get the question to open up. So I think we'll call it good. So you can finish up that assignment on your own. And again, don't hesitate. I am, at home today because I'm not feeling well, but I am checking my email and I'm happy to address any questions that you might have through email. So if anybody has any questions now, you can submit it over chat. We've got 6 minutes left, I guess. But otherwise, if you wanted to go ahead and log off, you can do that. But I'll hang back for a minute just to see if you have any questions. Okay, well, I'll take that as a no question. So we'll go ahead and call it good. And like I said, I'll post this pretty soon, and you can refer back to it. And of course, you have access to the assignment as well. All right, thanks everybody. Oh wait, could you walk through question 10? Okay, so somebody's asking about question 10. So I've got 5 minutes left. So if you want to hang around, I'll try and see if I can get question 10 going. For some reason, I'm having technical difficulty. So I don't know that I can walk through question 10. What I will be able, maybe what I can do is just do it on the screen without bringing actually up the question. Let's see. Okay, so draw the skeletal bond-like structure of 2,2-dimethylhexane from the condensed formula. Oh, I keep. Okay, so I'm not going to do it from the condensed formula. I'll do it from the name. So first of all, hexane is a 6-carbon chain. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and so this means at the 2 and the 2 position. So this is carbon 2. There's this two more methyl groups. So it would look like that. So you just basically you want to build that into the drawing tool. That's really bad. Okay. So yeah, you can see now for some reason it decided to show up. But with the condensed, the big thing with the condensed is remember that whenever you see a group in parentheses, okay, that means it's attached to the previous carbon. So each of these CH3s, there's 2 of them, is attached to the previous carbon. And you can see that. So there's that CH3 is right there. That carbon is right there. Those 2 methyl groups are there and there. Okay, and then a CH2 there, another CH2 there, that CH2 is there, and then that CH3 is there. Okay, so hopefully that helps finally. I know that was kind of a clunky way to get to it. I'm going to show you what a ketone is. On the paper it has a double bond to an O and then connected to an H, while in the notes it's double. Okay, so in the notes, there might be a mistake in the notes. So somebody has asked, can you show what a ketone is? Yeah, real quick, I'll show what a ketone is. A ketone is where you've got a carbon with a double bond to an oxygen in the middle, and then both of them are connected to carbon-containing groups. Okay, an aldehyde is where one of them is a carbon and one of them is a hydrogen. You'd have to show me specifically where in the notes, what you see. It could be an error, but this is an aldehyde. This is a ketone, and this one is an aldehyde. Okay. So if there's somewhere in the notes where it says that this is a ketone, that's an error. And if you point that out to me, wherever it is, I'll get that fixed. But this is a ketone. Okay. All righty, gang. Once again, sorry for all the technical difficulty. All right, and then once again, I think I'll wrap this up because we're getting towards the end of our time, which I didn't even know there was a time limit on it, but maybe that's a new thing. But just email me if you need anything else. Appreciate it. We'll call it good.